Autonomous system 1, autonomous system 2, autonomous system 3, then they interconnected together, right? So inside of this, each router, then you have two tables. When you want to connect, reach everything in the network, say for example, if you want to connect it to the Ocean Connect, or you want to connect to registration system or something, that's interdomain, or the servers is in Ocean County College. So that's for the intra AS routing algorithm. So this router will learn that which was the best way to route your packets to. But if you are going out, say you're in the class, you want to access Google, Yahoo, or Amazon, these places, then that request network connection is going to another autonomous system. So that table is have the inter AS routing algorithm. But in that kind of situation, probably you can imagine that the task is much easier. Reason the intra-AS routing, it's limited number of the routers. Say here we have a if there's any change, I was counted last year. It's 19 routers. 19 routers forwarding table is a simple one. You don't have to know millions of the routers outside. But if you are going outside the world, do you have to know everything anywhere like Google, where is Yahoo, and where is Amazon? You don't. The only thing you needed to know is where is the door to go out. Okay. The only thing you need is where is your gateway to go out. And you may have one gateway, or you may have two gateways. The gateway, say for example, in this connection, you have one gateway to go out, another gateway to go out. So these are, you have only limited number of choice of a gateway to go out. So what type of network you are forwarding to, and this routing table will provide you the solution. So in this manner, then the routing table will be much smaller than we expected. Okay, that's why we have autonomous systems. That's this picture. Then the inter-autonomy domain tests. Then you have a different thing. In the internet, multiple autonomous systems are connected in different ways, right? And every day is changing for this one. Now, these are the routers that are all internal. They don't deal with external network. They don't interface with another autonomous system. And in any company or any network, then of course you have a connection to outside world. So at least you have one gateway router connect to outside. Like this one, I have two. This one and that one. This one has two. This one and this one. And a very few company has only one. Small company, your personal business or small business, then you connect to the service provider. So your router is the gateway. Um, then maybe you don't need a large scale network. For a large network, then you want business reliability and dependability. So always you have multiple routers to rely on. In here, Ocean County College, the main carrier is Comcast and the other carrier is Verizon. Okay, so if Verizon crash, then Comcast will take care of data. If the Comcast doesn't work, Verizon take care of data. So you always have a connection. That's why we have a multiple connections from those multiple gateways. And also this gateway, they also carry the information like this. So if have the connection, this is the Verizon, that's a Comcast. If I have this one, what if Verizon has some information want to send to Comcast? They go through our routers. So this router has no send to this router and they go up from that one, right? Would that be okay? So this is a, for example, this is a Verizon, this is a Comcast. And the Verizon is sending the packets through Ocean County College to Comcast. Do you think I should be allowed that? Verizon is like Verizon the company is a large carrier. They have a lot of traffic. We are compared with them. We're running small business. We can carry a lot of packets. And also we're private network. We're in here. What hell would we have to carry the load for Verizon and for Comcast? No. We only know how to route packets out. And if you want a packet to come in, I want to make sure the destination is within here, not some another autonomous system. Don't bypass the packets from my link. Okay, so this is very important for the autonomous system routing. They have to make sure route these signals. That's the network administrator has to do. Okay, so this is explanation for this one. Suppose the router one, the router in AS1, autonomous system one, receive a datagram. Destination router is outside of AS1. So the router should forward the packets to the gateway router, but which one you have to pull it out. Say if I'm here, if I have a package to go out, then you have to carry that out. And if you type to say google.com, then your router must be able to determine that google.com shall go out this way or go out that way. That's the intended routing will decide. And you have only two choices. Then it's easy to calculate what's the right one, right? And then if you use the link state, then this will tell you what to do. If you use a vector, then you can test this one or that one, which one's cheaper, faster, then you will go that way. So that's the one. The autonomous system one will learn which destination are reachable. Some of them are not reachable, but most of them are reachable. But which one is easier to get there? And this message has to be passed to all the routers in the autonomous system. Then once you determine, say, okay, Google.com, I want to go out from Comcast. The router 1B will take care of that. So this is broadcasted to all the routers. Tell these routers, if you want Google, come to me. Okay, so that's the internal routing work about. So there are some protocol that the network management and the routing management does not carry any communication. The router is talking to themselves to form the networking function. So this is not protocol, every protocol are carrying all the data to for your communication. Okay, they talk about themselves a lot. So what's the thing? Now, if you have an intra within the autonomous system, the intra autonomous system routing, uh, also called the IGP, Interior Gateway Protocol. Okay, the Interior Gateway Protocol, there are many protocols, different manufacturer of the router, they have their own protocol, and but the standard ones, you have RIP, rest in peace. And that's the best protocol for packets. If you receive packets, just throw it away, right? Rest in peace. Okay, it's the routing information protocol. Okay, this one uses a distance vector. Everyone, remember distance vector? Just ask the neighbors who can get it. Which one cheaper? So that's the routing information protocol. And also the IGRP. The IGRP was a Cisco protocol for proprietary until recent years. Then it became public public domain protocol. So IGRP also uses this vector to calculate what's the routing and also broadcast information. That's what we will do. And the other one is OSPF, Open Shortest Path First. That by its name you can see that which link is open, you select. shortest, which is the open and shortest one I will select. So open shortest path first, that's a protocol. And that has another name. That was even more popular than that's called ISIS protocol. And suddenly become when ISIS become our enemy, and this can become a forbidden words. So all the writing companies are okay, we change the name. We change the name. Since this is extremely close to the OSPF, now they are also changing to OSPF, but actually they are slightly different. They're slightly different because of the parameters and the algorithm determination is different. So if you see the ISIS, it's not from Middle East, so don't worry about that. That's what you call them. Okay, then that term ISIS is very popular. That I remember in Verizon there is a project also called ISIS. Once that happened, then Russia changed the project name to a different name. And then a lot of words you want to avoid. That's a political driven thing. You never know. And if the name like a Google, if we use it by a terrorist group, I think that the Google will change it to Google, right? So that's the other thing. Okay, this OSPF uses a link state algorithm. So this OSPF, it has to know all the router situation in order to make a decision. Which one is open and which is the shortest path. If you don't know the path, how could you find out what's the shortest path, right? So by nature, it knows the topology of the network. Then it can make a decision which one I should go. So that's the only link state algorithm inside. Now we know that autonomous system may not be very complicated, may not be very big. So the link state is a suitable or doable. Uh, OSPF, say in Ocean County College, I have only 19 routers. Most of ours classroom building routers, so it does not go across the building. Very few chance you have one computer on this classroom or talk to another computer in that classroom, right? So that's the way they can do. A link state happens very easy to calculate. And if you're in a large network, large company network like Verizon, AT&T, or Sprint, those networks, they have hundreds, thousands of routers. Then OSPF protocol inside will be very difficult. Only the large routers have the capacity to run. The small routers will not be able to do that. But still, you can break this network into the sub-autonomous system. Make it look like autonomous system locally, but it's still within the big autonomous system. Okay, so that is a local domain. You can do that too. And large company always do that. Then in the company I work with, in that time it's a Lucent after the spin off from AT&T, right? The Lucent we have Bell Labs domain, we have information system domain, we have the customer service domain, and these are the local domains within that company. The company is the Lucent Technology domain. So that's the way we divide the network. Okay, here are some little explanation about OSPF. Open shortest path first. Open, that means public available. The public available is really means available. Sometimes you have the connection, but it's not available. Just like Verizon want to go to Ocean County College and send the information to Comcast. We should not allow them to do that. So this is not openly, publicly available. It's open so again, but it's not publicly available for them. So that's they cannot choose that. And also it uses link state algorithm. The link state packets will send out to all the routers. And then they get information, okay, I'm router A sitting here, and router B sitting there, what connection I have, and this information will send it back to that router, and that router will have a global picture of the network I'm sitting inside of Ocean County College, for example. Then once you have this one, it has a topology map of each node and all the uh, routing information they can. Then when you do this one, the router will send the information advertisement to all the routers within that autonomy system. Say, hey, I'm the router here. Tell me the global picture. Okay, then once you receive this one, and other routers will tell that router that network configuration, current network configuration, and where it fits. And also at the same time, this router is also telling others that where I'm set, what connection I have, and what's the cost of each connection. So this one is the OSPF message directly over the IP, the layer. So it's not the TCP or UDP, right? It's like from IP level to send out the network layer. Why it's not a TCP UDP? Because TCP UDP is a transport layer. And we're doing a network. We don't supposed to touch higher layer. So IP is a third layer protocol. We strictly use IP protocol to do it. The link state is the avenue used to test. Okay, that's another uh, disclaimer that ISIS is the routing protocol is nearly identical to OSPF. So that word, forbidden words, people don't want to speak. Okay, now how about the different ISP, internet service providers, how they communicate to each other? Because we have these protocols, RIP, right? In IGRP, these are the algorithms we use to determine the internal networking structure. And also I have OSPF I can use to determine infrastructure internally and how to route. Then when I connect to the service provider also connects to other service providers. How they talk to each other? That's internet. That's what inter-autonomous system routing protocol, right? So we have a BGP. BGP is for the border a gateway protocol. Border is on the edge. Okay, the edge network, edge router want to talk to each other to configure network connections. So this is the inter-domain routing protocol. That protocol pull all internet together. Every autonomous system is a network, it's local. Then this with BGP will put all the network together. And as long as you are not uh, like a self-contained network, then you use the BGP to connect to others. But the BGP has two parts, interior and exterior. It's called eBGP or iBGP. Why? Because any communication you have inward and exward. Okay. When you coming into this one, that protocol has to determine where you go inside. That other at the same part, internal network they have a request to go out where you need it to go. That's also we have to specify. So the BGP provider, this one is an eBGP, sends the subnet reachability information from neighboring autonomous systems. Just like it also asks other neighbors autonomous system, like Verizon come up with it as AT&T, where you can reach and what do you have, and then the next one the Comcast, what you have, where you reach. So it reach that use eBGP to talk to other service provider, the autonomous systems. Then iBGP is interior. Interior one is to propagate the reachability information to all the autonomous system internal routers. If I use Verizon service for this we don't use Verizon service here, we use Comcast service. The Comcast, the IBGP will tell us, okay, if you want to go Google, take this way. If you go Yahoo, go that way. And Amazon, go this way. Whatever you want to do, it tells inside. So IBGP is as a neighbor. Okay. No, sorry. EBGP as a neighbors. IBGP tell the household people so how you get out. So determine a good route to other network based on the reachability information and the policy. The policy is I said you have the connectivity but may not allow the traffic to go through. So we have two routers. One connected to Verizon, one connected to Comcast. Comcast is going out. Verizon will also be sending things out. But the network connectivity is there. But what if Verizon want to pump traffic through us to connect it to Comcast? Comcast is pumping traffic to us want to get to Verizon, or Verizon wants to get it to Comcast, then the policy will not allow it. So that the BGP also determines the policy. Where you can go, where you cannot go, even though the link exists. But that link exists. But then people say, why do you need it? And we just cut it. No, we don't cut it. Why? That company internally need to use that, right? And also the other thing is you need to allow this protocol to go through. Then this protocol establish a network, tell you where you can go, where you cannot go, but does not allow the traffic to go through. The user traffic cannot go through. So that's very important. Then the BGP is always allow the subnet to advertise its existence to the rest of the internet. So I'm here, I'm this Ocean County College, and this one is on the internet access, you can go through the DNS, right? But for the network, you have to go through the BGP to let other routers know this network exists. They don't go by the company name ocean.edu or google.com. It goes for the network IP network address. So tell the network address, if I have this network address, come through this one. Okay, so that's it. Okay, now here is the illustration for EGP, BGP, and IBGP here. Autonomous system 1, 2, and 3. And IBGP connectivities, it manages the inside of network, and EBGP knows where to connect to another autonomous system going through this way. And these circular ones are the gateways. The gateway router connected you this network to another network. For some of the network, you have only one. For some of the network, you have multiple ones. For the service providers, they have a lot. These are the gateway, or sometimes we call it edge gateway, or border gateway. Okay, now this one is some kind of a operational picture, how we see that. That BGP have advertisement. And let me see where's the animation. Okay. The first step is if I have AS autonomous systems 3 that X want to talk to let me see where is it come from okay. The autonomous system 2, router 2C receive the packet from an advertisement from ASC, autonomous system X. Okay. Then this is what you protocol carries is EBGP because across the autonomous system, right? Then once you have this, say I have a router 3A connected to this one, I get your advertisement. Then I know the connection exists. This one is going to broadcast to all the routers in here internally. Then that means if you want to go there, go through me. So that will do. But now there is one special situation. Go through this router. Now this router will look at it. Okay. Now I want because I have another external connection, right? Should I tell them? Should I tell them and tell them? available, then this is the decision you have to make. Based on autonomous system two's policy, the AS2 router 2C accept the path for this one, propagates via the IBGP to or AS2 router. Okay, that's it for this one. For the second step. The third step is based on that this policy. This router 2A may or may not advise this path to their friends. Say, okay, if you want to advertise, let them know. So, okay, it's message from autonomous system 2, and there is a way you can go out from autonomous system 3 to X. You may tell them or you may not tell them, but most likely it will tell the one C along with the restriction. Say, only routing protocol, no packets, no data packets. So that means it's private. And if it's a service provider, they have an agreement, that means they want open. So this is AT&T, this is a provider, this is Comcast, most likely it's open to all. Okay, I'll let you know if you want to use traffic, go through this because these are like a trade and vice versa. You use mine and I use yours, so they don't block each other. So that's depend on your policy. If it's private, you don't tell, or you tell them it's limited. Okay, then the BGP routing. The route the routing protocol is used to select which route to go, right? So the selection is based on what? And the router may learn about more than one route to the destination. And this way you can go that one, you can go. How you choose that one? Okay, first the local preference value attributes policy decision. You can go this way, okay, you cannot go this way. Okay, so that's the one. And then after the policy choice, then this one you want to choose the shortest autonomous system method. The shortest path. First, the policy has to go allow you to do that, and the second one you go to the shortest path with allowance. Okay, then you can choose the closest next hop router. If there is no direct connection, then you can go to next hop router. But that's sometimes called hot potato routing. You once you get it, you throw it out right away. You don't want to keep it, right? And there are some other criteria to say, for example, if you want to go travel, right? If you want to travel, if you want to go to say Lebanon or some that area, more area, now you know which way to go is the shortest. So you can take a flight to somewhere to that area directly. But then you have to ask the policy. Can the US government allow you to go there? And the Russian government allow you to go there? First you have to see the policy. If the policy doesn't allow you, even you to your next door, you cannot go. Have you seen that kind of a funny video say that one house is on the border of two countries? Front door is one country, the back door is the other country, right? So if you want to do that one, you can go inside of a house to go to front door to the back door. But if you go front door, go through your yard to your back door, then you need a passport and visa. So that's the thing. That's the policy will govern the capacity. And after policy allows, you can select the shortest. And also, if there is no direct one, they want to find the closest next hop router. I give it to you, you give it to him, do it as quick as possible. Shortest. And some other criteria to restrict. So these other criteria are usually associated with the bandwidth, cost, and congestion. You don't want to go into, if you are high speed, high bitrate video, if that link is very slow, you don't want to get into that, even though it's short, very short. Or if it's available at high cost, like a satellite link, whatever, you want to consider again and again if you want to use it. And then the other thing is that traffic is always getting jam over there, like very congested link. Also, you want to choose, okay, maybe I use something else. So these are the BGP routing selection criteria we do. And why we have different use intra and inter system routing, why have to be different? Now we have the pictures. Internet is a network of networks. You have a small network. The small network is treated as one node, put into bigger network. Then probably you would think, okay, these networks are considered the same way. Why can't we use the same algorithm to do instead of using intra and inter autonomous routing? Well, the world is not owned by one person, not owned by one country, not owned by one company. So the policy is the key player. Okay. Inter-domain, in the intra-domain, each autonomous system is owned by one entity, one company. Okay, when you do the network, each autonomous system is a different company, different service provider, and you have to consider that when you do that. Just like you travel, you can travel within the United States everywhere, but if you travel to foreign country, you have to carry a passport, get the visa, and go through the customs office. It's not local. So that's the same situation. Policy is everything. And also the scale. Small is a small, large is a large, different amount of traffic you're talking about, and you really have to consider the hierarchy of routing to govern that. This is when we talk about a computer network, the networking issue, the performance is one of the key points. So that the scale and the performance will determine that. The performance, the intra AS, then you can focus on the local information performance. The reason is just like the internet, we don't have to consider security and everything is like internal, you are okay. But if you are inter autonomous system plus the network, then you have to do a lot of the things. Not only the performance, also that the cost and security and network congestion, delay, etc. These are all into the consideration. So there is no fixed formula for the network routing. And the part of you are learning the network, being a very experienced the network administrator, you have to know all these policies and available links. Then you can teach the router to understand what to do, make a decision. The router, if you let the router do everything by itself, then it will cross the border and do some kind of against the policy, everything will do. So that's what you need to control. Okay, so that's that part about routing. We have the basic introduction, and for this course, we're not going into detail about how to set up the routing protocols and how to set up those parameters and how to figure out, you know, we have one course, we haven't gone through the full yet. It's for the modern fundamentals. And that course we can learn how to provision the router and those kind of detail. Uh, it's not book yet. But we have another course. The next semester it's another it's networking two. After this course, the networking two, we're going to do the similar things. All these same textbook, same material again. We just go different depth, different detail, and that also we put our hands on. We can do a couple of small network in the class and have hands-on feeling about it. So if you're still in Ocean County College, not graduated yet, I always encourage you to take networking too. I'm also teaching that. And we have these computers, and have routers, and hotspots. And we can do a lot of the practice, the play with. Last year we don't have enough students, so we canceled that class. But the coming year, 2020, I think we have enough students. It's nice time slot with the Okay, next part we're talking about is SDN uh, control plane. Software-defined network is our goal for the future we want to do, right? SDN is really preferred because it has the global picture of the network infrastructure and then knows what's the cheapest and best and fastest way to route the traffic. So it generates the routing table, put to the routing and forwarding table put out each individual router. So the router can follow the instructions to do that. That's ideal situation, but it's still having a lot of issues. Okay, the software-defined network is that approach. Then in the internet networking layer, we always traditionally we always use each router is individual. It's a per router approach, right? And then the problem is that that's got a monolithic router contains a switching hardware, runs a proprietary implementation of the Internet Standard Protocol. They have each router has their own IP protocol, WIP, or OSPF and BGP, and in a proprietary manner, like a Cisco routers or something. Okay. Now, how many routers company we have? We have a lot, right? Cisco is the kind of the biggest one. The second biggest one actually now it's not, it's in the worldwide, it's not the, Cisco is not the biggest one. The worldwide, Huawei is the biggest one. Then Cisco, Juniper, Alcatel, Lucent, now it's a Nokia, and Riverstone. Anyone knows any other routers in Bahrain? Before we have a Linksys, not bought by Cisco, and then before we have Newbridge, we have Northern Telecom, and we have so many routing companies. Every router they have their own protocol, own proprietary protocol. They are all very similar, but they're different. Why different? They want to be the same, but if they are be the same, the first time they patent the routing algorithm, they patent technology. If I use the same one, I have to pay the royalty for that. But no, I want to have my own algorithm, slightly different, but doing the same work that you don't have to pay. Then that one will cause incompatibility because you have different way to make a decision. If the packet is walk from here to there, then it's like a twisted. Okay, so it's not exactly the same. So you are really having different the routers and different protocols. So then you have a lot of middle boxes to connect in between. The main part is the network address translation. The net routers that you translate these the things we have. Now solve this problem starting from the theoretical started from 2005. Okay, that time actually I was in the Dell lab. I read that kind of article. I said, yeah, that's a good idea. Then who want to do it? Who can start to do that? Then it drags on and on. No one really stepped into that. Just like I said, oh yeah, we have a good idea. Anyone want to do it? Or the service provider manufacturer said, let's wait, let's see. So it really wait until recent, uh, like wait 4 or 5 years, then that happened. Then started, I think that these companies suddenly decided to jump into that and triggered by Amazon, IBM, Hewlett Packard, and these companies. Okay, let's do it together. So they started something called software-defined network, and logically centralize the routing calculation. Use one computer, one big, not huge computer. It's like a bigger than the router. The router itself, it's a router. It's a small computer in there. It's a dumb computer, not faster than your PC or laptop. But this computer is a reasonably faster, like a cluster of servers, and they can calculate all networks. What's the best connectivity and what's the best situation? So that's simple. So this approach, so in easier network management. So network management, before you are connected to the router, you as a person have to have the global picture. The router has a picture, but only the router knows. You cannot, it's hard to translate into your language. You have to know network connection. Then you have to interface with your router and change to that. It's management, network management is really a big task. It's not easy job. That's why the network administrator, the top level, is highly paid. It's not uncommon to have a 200,000 to $500,000 salary for this network administrator. Okay, they just sitting there, change a route, change something, but you do have to have the global picture to do that. Now, with that approach, you don't have to. Everything the computer knows, computer will decide, and you only look at the picture. Okay, this is wrong, this is the traffic. Unless you want to make some menu enforcement change, then you don't have to do anything. So that's network management will be much easier. So avoid the broader misconfiguration and very flexible. And also that table-based forwarding allowed allow you to program in the router. This one is just pushed down to the router. The router just follow this table and do the communication. It's easy. And also that the idea when they started, it's open. It's not proprietary implementation or the control plane. That everyone can jump in. Now here comes another part. Everyone jump in. Yes. So far, I know at least in this country, more than 50 big companies jump into that already. And once they jump in, they do their own work. Once they do their own work, no one talk to each other. I have my way to improve it. You have your way to improve it. That everybody is managing their own system. And once that time, I was involved in the Verizon part of the software-defined network. Then I was thinking, I said, let's do the software-defined network. But what if we are crossing the network? Then what do? They said, no, we don't care. Unless they follow our standard, we don't talk to each other. And that time I asked them a question. Do you have a forward looking? Because my job is the strategist. I will have to do the forward looking. I said, if you do this one, that's okay. If you don't do that. So what if tomorrow your Verizon is expanding, you want to buy AT&T? Then can you merge the network or you want to start from scratch again? No one can answer me this question.
I think starting off from scratch.
Because everyone do their own. You you can manage it. Say AT&T manage their SDN network, no problem. That's called the domain 2.0. Verizon has their own SDN. They call it global 2. These two systems are different. They are all both are SDN system, software defined network. They communicate in different ways. So they're okay because these are two different domains, right? They just pass the traffic around. They don't have any conflicts. But what if one company is going to buy another company, become one network? Then you have to, at least you have to destroy one of them. So that time I raised this question. As anyone can answer me this question when you do the development, at least you're looking to other companies for the compatibility. So no one has compatibility. Amazon is the leading. Uh, Hewlett Packard is fastest in speed, and IBM is the best in service, and EMS is a large network storage, and they are all just they wear their own shoes. No matter it's a shoes or a sneaker, whatever, they work on their way. I want to see in the future what will happen. This company, it's not going to forever stand as a lone company, right? There will be merge and acquisition. I want to see what kind of funny thing will happen. No one can answer my question. Okay, so that's SDN selected challenge. The SDN is a hardware control plane. Okay, it's a dependable and reliable, and the performance is scalable, the secure distributed system. Okay, that's the good thing. And the robustness of the failure. So it's not easy to fail that system because once if you have your router failed, then this system is going to reconfigure the network in the best way in a fraction of a second, then download the new routing table to the router. So the network outage will almost like you cannot feel it. That's very quick, right? Then reliable, then that's another problem. What if that system crashed? Now, currently we have each router is independent. If this router is crashed, then you just don't carry the packets. And if someone sends you the packets, then this you don't respond it, you will find another way to deliver the packets, right? But if in that one, if it crashed, no one knows what to do. You have one big board on the top, the other one is the follower. If the big board is dead, then the chaos will happen. That's one thing, right? And also the security. Uh, yeah, it's kind of a thing you really have to think about. What if someone attacked that server and that caused a full network outage instead of each individual? So then this router, these hackers will not attack each single router. They attack the control system. And also that they have the advantage of the internet scanning and some kind of mission specific requirement you can do that. The mission specific requirement, for example, uh, today you can do this like AWS, Amazon. If you have a new company, before any company they have their IT organization, they have network specialists to set up the router for everything, right? If I today I say I want to start community college like this, I said I have 10 buildings. Each building have 10 classrooms. Each classroom have 20 computers. This kind of situation. I said I want to have everything set up. Then I just talk to Amazon. Amazon say, okay, I'll run fiber to your school. You connect the fiber. Then from this fiber you connect to switches and the routers. You just plug in. Okay, you don't need any special people. Just plug in all the layout. Then everything is controlled and delivered by Amazon. It's a software-defined network. You say you have 10 buildings, each building have 10 classrooms, each 10 classroom have 20 computers there. These are all configured. Then today, if you say, okay, now this building is in menace, I want to shut down. You just drag this building out. Say, okay, it's done. You don't have to do anything. Everything is configured. So that's why we say the convenience is there. There is no need for the IT organization to do the body network setting. And at that time, if every company is doing like this one, so these people can as network experts or network administrator, they lose their business. Okay, they lose their job. They don't need it anymore. The one they need is only the person just drag the mouse, drag the picture, configure